Hello, my dear students. How are you all? I am fine. I am Khandekar Fazle Rabbi, lecturer, Department of Chemistry, Milestone College, Uttara. My dear students, during this pandemic situation, welcome you all to our online chemistry class. Today, we discuss about some important creative question from chemistry first paper, chapter 3, periodic properties and chemical bonds. My dear students, here given our first stem, here given the element and electronic configuration of the outermost shell where n equal to 2. My dear students, here n equal to 2. So our first element and A and electronic configuration ns2. So my dear students, we can write A electronic configuration ns2. That means n equal to 2, so we write here 2s2 and 1s2. So we can say that here the element A represent beryllium. Now my dear students, element B 2s2 2p1, B 2s2 2p1. We write the previous electronic configuration 1s2. So here 5 electron is present, so we can say that this is boron. So B represent element boron and D equal to ns2 np2. That means n equal to 2, so we can write 1s2 2s2 2p2. Here 6 electron present in this electronic configuration, so we can say that D represent element C. D represent element C, that means carbon. And here X, here the electronic configuration n plus 1 s2 n plus 1 3. Here n equal to 2, so this is n 2 plus 1 3s2 3p3. So we can write 1s2 2s2 2p6 3s2 3p3. So we can say that X represent element P, that means phosphorus, and the last one Y, here given electronic configuration ns2 np3, that means 2s2 2p3. So we write here 1s2 2s2 2p3, and we can say that Y represent element N, that means nitrogen. So A is beryllium, B boron, D carbon, X phosphorus, and Y nitrogen. And my dear students, here our first question, analyze the structure of the chlorides of A and B. We can see that here A is beryllium and B is boron. So the chloride of A and B are beryllium chloride, BeCl2, and another one is boron trichloride, BCl3. Here our second question, Y forms only one compound with chlorine but X forms two compounds. Analyze. My dear students, here we can say that here X forms only PCl3 and PCl5 compounds, and Y forms only NCl3, nitrogen trichloride, but X forms phosphorus pentachloride and phosphorus trichloride, my dear students. And our next question, why the structure of two hydrides of D, D2H4 and D2H2 different? Explain. Here according to the stamp, we can say that D2H4 is ethene, this is ethene, D2H4 is ethene C2H4, and another one D2H2, D2H2 is C2H2, that means ethine. Now, my dear students, we discuss about the answer of these questions. My dear students, here our first question: analyze the structure of chlorides of A and B. According to the stem, we can see that the chloride of A is beryllium chloride, BeCl2. My dear students, here the center E, atomic number 4, electronic configuration 1s2, 2s2, 2px0, 2py0, 2pz0. My dear students, in excited state, one electron of 2s2 orbital shifts towards 2px0 orbital, and we can write here, this is excited state, beryllium 4, 1s2, 2s1, 2px1, 2py0 and 2pz0. My dear students, in this stage, one s and one p orbital mixed up, and they form two identical sp hybrid orbital. This is hybridizing state, and beryllium 4, 1s2, it forms two sp hybrid orbital, sp, and here 1 and 1 electron present, so we write here 1 and 1. Now this sp hybrid orbital overlaps with the unpaired electron of chlorine. We write the electronic configuration of chlorine here, chlorine 17, 1s2, 2s2, 2p6, 3s2, 3px2, 3py2, 3pz1. My dear students, and another chlorine, here two chlorine is present, so we write here another chlorine 3pz1. So my dear students, here this sp hybrid orbital now overlap with the 3pz1 orbital, face to face overlap occurs here, and they form two sigma bond. This is sigma sigma. My dear students, if hybrid and non-hybrid orbital overlaps, then there forms sigma bond. So we can see that here two sigma bond occurs, and now we can write the shape of beryllium chloride. Here beryllium, this is beryllium, 2 sp hybrid orbital, and this sp, this is sp, this sp hybrid orbital overlaps with the p orbital of chlorine. Here p orbital is dumbbell. So this is the shape of beryllium chloride. There are two electrons. This bond is named sigma bond. This is also known as sp p bond, because here sp hybrid orbital overlap with the p orbital of chlorine. sp p. So the shape of this compound, shape linear, and bond angle chlorine, beryllium, chlorine, bond angle 180 degree, my dear students. Here the bond angle is 180 degree. So the shape of beryllium chloride is linear, and the chlorine beryllium chlorine bond angle is 180 degree, my dear students. My dear students, now we discuss about the structure of boron trichloride. According to the stamp, chloride of B, that means boron, is boron trichloride. This is boron trichloride, my dear students, BCl3. Here the central atom of boron trichloride is boron 5. Electronic configuration 1s2, 2s2, 2px1, 2py0, 2pz0. My dear students, in excited state, one electron of 2s2 orbital shifts towards 2py0 orbital, and here we get the electronic configuration B, 1s2, 2s1, 2px1, 2py1, 2pz0. My dear students, in this stage 1s and 2p orbital mixed up together, and they form three identical sp2 hybrid orbital. This is hybridizing state. Boron 5, 1s2, 2sp2, 2sp2, 2sp2. My dear students, here one electron present in spxpy, and that's why we write here 1, 1 and 1, my dear students. Now we write the electronic configuration of chlorine. This is 17, 1s2, 2s2, 2p6, 3s2, 3px2, 3py2, 3pz1. My dear students, now here 3 chlorine is present, so we write here 3 chlorine, 3pz1, another chlorine here 17, 3pz1. My dear students, here in 3pz orbital one unpaired electron is present, and that's why the sp2 hybrid orbital with one unpaired electron overlap, face to face overlap with the 3pz1. Here 3 sigma bond occurs. That means 3 face to face overlap occurs here. This is sigma, sigma and sigma. And my dear students, now we write the structure of boron trichloride. This is the central atom of boron trichloride is boron. This is sp2 hybrid orbital, sp2 hybrid orbital, and this sp2 hybrid orbital overlap with the p orbital of chlorine. And we can see that this is the paired electron, and sigma bond occurs here. So this is sigma, sigma, sigma. We can also name the bond is sp2p, sp2p, sp2p. So the shape of this compound is shape trigonal planar, and bond angle is 120 degree, 120 degree. So chlorine, boron, chlorine, bond angle equal to 120 degree. So we can say that the shape of the chloride compound of boron trichloride and beryllium chloride are different. My dear students, this is our next question. Y forms one compound with chlorine, but X forms two compounds. Explain. My dear students, according to the stem, we can say that Y represent nitrogen and X represent phosphorus. So we can say the chloride compound of nitrogen is NCl3 and chloride compound of phosphorus is PCl3 and PCl5. Now we have to explain why nitrogen forms only nitrogen trichloride, but phosphorus forms phosphorus trichloride and phosphorus pentachloride. Dear students, if we see the electronic configuration of nitrogen, here we write here 1s2, 2s2, 2px1, 2py1, 2pz1. My dear students, here we can see that no vacant orbital is present in second shell, and that's why this electron cannot be shifted, and that's why nitrogen only forms NCl3. That means 3 pz, 1 orbital of chlorine overlaps with this unpaired electron holding orbitals, and that's why we get only NCl3. But my dear students, if we see the electronic configuration of phosphorus, this is 15, 1s2, 2s2, 2p6, 3s2, 3px2, sorry, 3px1, 3py1, 3pz1. Here 3 unpaired electron present in the outermost shell of phosphorus, and that's why these unpaired electron holding orbitals overlap with the p orbital of chlorine. That means 3pz, 1 orbital of chlorine, and they form phosphorus trichloride PCl3. But in excited state, 3d xy, 3d yz vacant orbital present here. Here vacant orbital present here in the outermost shell of phosphorus. Then 1 electron shifts this 3d orbital, and we get 1s2, 2s2, 2p6, 3s1, 3px1, 3py1, 3pz1, 3dxy1, 3dyz0, and so on. So my dear students, if we see the electronic configuration here, 5 unpaired electron is present. That's why 5 chlorine can overlap these 5 unpaired electron holding orbitals, and then they form phosphorus pentachloride. And according to this reason, Y forms only 1 compound with chlorine, and X forms on 2 compounds. My dear students, this is our next question. Why the structure of 2 hydrides of D2H4 and D2H2 are different? That means their structure is different. My dear students, according to the stem, we can say that D represents carbon, and that's why we can say that D2H4 is C2H4, that is ethene, and D2H2 is C2H2, that is ethene. Now my dear students, we discuss about the structure of ethene first. So here the central atom of ethene is carbon. This is carbon 6. Electronic configuration of carbon is 1s2, 2s2, 2px1, 2py1 and 2pz0. My dear students, here one electron in excited state, one electron shifts from 2s2 orbital to 2pz0 orbital. This is carbon 6. This is excited state, and now the electronic configuration is 1s2, 2s1, 2px1, 2py1, 2pz1. My dear students, here in ethene one carbon-carbon double bond is present. So here 1s and 2p orbital mixed up together, and they form 3 identical sp2 hybrid orbital. My dear students, 1s2, 2sp2, 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 and here non-hybrid pz orbital exists. My dear students, here 1 electron present, so we write here 1 and 1 electron, and this hybrid 2sp2 hybrid orbital overlap with the 1s1 orbital of hydrogen. This is, here we see that in C2H4 2 carbon is present, so another carbon is here 6. This is the hybridizing state, 1s2, 2sp2, 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 and one non-hybrid pz1 orbital, and this carbon overlap with 2 hydrogen, 1s1 orbital, 1s1, and this orbital contains 1 electron. And now this sp2 hybrid orbital overlap the 1s1 orbital of hydrogen. This one is also overlap with the 1s1 orbital of hydrogen, and here sigma bond forms because hybrid and non-hybrid orbital overlaps. This is face-to-face overlap, my dear students, and this is also sigma bond. This is sigma bond, and one sp2 hybrid orbital overlap with the another sp2 hybrid orbital of carbon. This is also face-to-face overlap because this is hybrid and this is also hybrid orbital, and this non-hybrid orbital overlap with the another non-hybrid orbital 2pz1, 2pz1. This is pi bond, my dear students. We know that if hybrid orbital overlaps, then sigma bond occurs, and when non-hybrid and hybrid orbital overlaps, then sigma bond forms, and another way non-hybrid orbital when overlaps, then that then forms pi bond. So my dear students, now we write the structure of this ethene. Here this is carbon, one sp2 hybrid orbital of carbon overlap with another sp2 hybrid orbital of carbon. This is the sigma bond of carbon sigma bond, and this sp2 hybrid orbital, 2 sp2 hybrid orbital of this carbon overlap with the hydrogen, that means 1s1 orbital of hydrogen, and this sp2 hybrid orbital overlap with 1s1 orbital of hydrogen. And now we can see that this here electron and this bond is sigma. This is also sigma, sigma, and sigma. We can also name this is sp2s, sp2s. This is also sp2s, and we can write sp2s bond. And now we can see that here one non-hybrid orbital of this carbon and one non-hybrid orbital of this carbon overlap, and this is pi bond, and this is this non-hybrid orbital of carbon, this carbon, and this is the non-hybrid orbital of this carbon, and they overlap, sidewise overlap occurs here, and they form pi bond, my dear students. And this is the structure of ethene, and shape here, shape is trigonal planar. So my dear students, this is the structure of ethene. My dear students, now we discuss about the structure of ethene. My dear students, here in ethene, the central atom is carbon. Here carbon 6, 1s2, 2s2, 2px1, 2py1, and 2pz0. In excited state, my dear students, excited state, one electron of 2s2 orbital shifts towards 2pz0 orbital. Then we get 6, 1s2, 2s1, 2px1, 2py1, 2pz1. Now in ethene, my dear students, 2 pi bond is present. So one s and one p orbital mixed up together. This is hybridizing state, and they form two identical sp hybrid orbital, 2sp, 2sp, 2py1, 2pz1. Here 1 electron present, so we write here 1 and here we write electronic configuration of 1 hydrogen, and here another central atom of carbon, we write here 1s2, 2sp, 2sp, 2py1, 2pz1. Here we write this carbon because here 2 carbon is present, and 1 another hydrogen, 1s1. My dear students, now hybridization occurs, and here one sp hybrid orbital overlap with the 1s1 orbital of hydrogen. Here sigma bond occurs because hybrid and non-hybrid orbital overlaps face to face, and here one sp hybrid orbital of one carbon overlap with another sp hybrid orbital of another carbon, and this is also sigma bond because hybrid and hybrid orbital overlaps. And here they present 2 non-hybrid orbital, and they overlap, sidewise overlap here occurs, and here we get 2 pi bonds, my dear students. Now we write the structure of this ethene. Here 2 carbons, central atom, 2 central atom is present here. This is the 1 sp hybrid orbital of this carbon, and another sp hybrid orbital of this carbon, and this sp hybrid orbital overlap with the another sp hybrid orbital of this carbon, and here one sp hybrid orbital of carbon overlap with 1s1 orbital of hydrogen, and here another sp hybrid orbital of another carbon overlap with the hydrogen, 1s1 orbital of hydrogen. And here, my dear students, this is the sigma bond, this is also sigma, this is also sigma, and we can also name here sp because here sp and sp hybrid orbital overlaps, and this is sp s or bond, this is also sp s bond, my dear students. Now my dear students, here we can see that here 2 pi bond is present, So we write here, this is the py orbital of this carbon, and this is the py orbital of this carbon. These orbitals are non-hybrid orbitals, and another pz orbital, this pz orbital of this carbon, we can write like this, pz orbital. This is the pz orbital of this carbon. So they overlap sidewise. This is pi bond, and they also overlap, pz orbital overlap sidewise, and sidewise overlap. And so according to the structure, we can say that the shape is linear. Shape is linear. My dear students, here sp hybridization occurs, that's why the shape is linear. And according to our discussion, my dear students, we can say that the structure of two hydrides of carbon C2H4 and C2H2 are different due to the hybridizing state.